How far can a single wheat grain go? It can stay in the field and become seed for the next season, or it can be milled into flour, turning into toast on the breakfast table, pasta in a restaurant, or a freshly baked loaf straight from the oven. Today, we follow a batch of newly harvested wheat as it moves through the modern grain processing and baking production system to see how the golden grains from the FILDAFTE are cleaning, milling, blending, fermentation, and baking fin all while reach people as tables. A note up front, equipment, recipes, and food regulations differ among countries and factories. What we present here is a common basic flow in modern wheat processing and industrial bread production. It is not a magic trick that turns wheat directly into bread, but a long chain involving agriculture, grain storage and transport, food processing, quality control, and logistics. It all starts in the wheat field. When the wheat matures, the ears gradually turn from green to golden, and the grain moisture drops to the harvestable range. Farmers plan the harvest according to weather, maturity, and local storage requirements. Harvesting too early means higher moisture content and increased drying costs. Harvesting too late risks rain, lodging, shattering, or quality loss. Large farms typically use combined harvesters. The machine cuts the stalks in the field, feeds the ears into the threshing unit, and separates the kernels from the heads. Fans and screens then help remove lighter straw fragments, glumes, and other impurities. The clean wheat kernels are temporarily stored in the harvester's grain tank, and then transferred to transport vehicles via the unloading system. This step may seem simple, but it directly affects subsequent processing efficiency. The wheat entering the grain trucks is not a uniform raw material. Different varieties, fields, and growing seasons can result in different protein contents, kernel sizes, hardness, and moisture levels. For a flour mill, understanding the characteristics of each batch is crucial because the flour's end use depends on its processing performance. The transport vehicles deliver the wheat to grain depots, intermediate silos, or directly to the flour mill. Upon arrival, the raw grain usually undergoes sampling and inspection. STAFF or automatic samplers take samples from various positions to check moisture, impurities, test weight, and any other non-conform MITIS. The specific tests depend on the intended product use, company standards, and local regulations. After passing inspection, the wheat is moved into storage bins, but before it can be milled, it goes through a more rigorous cleaning process than the field cleaning. First is screening. Sieves with different apertures remove larger debris and smaller fine particles. The air classification uses air currents to carry away light impurities such as dust, broken husks, and straw fragments. Destoners rely on differences in particle density and motion to remove stones, sand, and other heavy foreign matter. Magnet IC separators catch any metal particles that may have entered the grain, protecting downstream equipment and reducing food safety risks. Wheat is not necessarily washed directly with water like fruit. In modern milling, cleaning usually involves screening, air aspiration, destoning, magnetic separation, and surface treatment. Whether water is used and how much depends on the process design. The key objective is to remove impurities as thoroughly as possible and prepare the grain for milling. After cleaning, the wheat often undergoes tempering moisture readjustment. The mill adds a controlled amount of water based on the wheat's hardness, initial moisture, and the desired flour type, then lets the wheat rest for a period. This is not to soak the grain into a paste, but to allow moisture to gradually penetrate the kernel structure, making the outer bran more flexible and the endosperm easier to separate and grind. This step is extremely important. A wheat kernel consists roughly of bran, germ, and endosperm. Most white flour comes mainly from the endosperm. While the bran and germ have different uses, proper conditioning enables the mill to separate these components more effectively, reducing bran fragments in the flour and improving milling stability. Next, the wheat enters the milling system. Why people imagine that milling is simply putting grain into a machine and grinding it to powder in one pass. In reality, modern flour mills typically use multiple grinding and sifting steps. Wheat first passes through a pair of roller mills, steel metal rolls rotating at different speeds that gradually crush or shear the kernels. The goal in the first break is not to reduce everything to a fine powder, but to open the grain structure and release the inner endosperm. The material from the first grinding goes to sifting equipment. Sieves classify particles by size. The finer fraction may already be close to flour. Larger endosperm particles are sent to the next grinding stage. Coarser bran is separated out to prevent it from being repeatedly pulverized and affecting flour color and purity. Thias cycle of grinding, sifting, regrinding is repeated many times. Each step does one thing: recover as much usable endosperm as possible from the bran, and process that endosperm into a stable, fine powder. Modern milling is a precise process where equipment settings, screen configurations, wheat blending, and moisture control all influence the final result. Flour mills often blend wheats and flours according to end-use requirements. Not all wheats are suitable for the same food. Flour with higher protein content and stronger gluten properties is more often used for bread products that need structure. Flour with lower protein or weaker gluten may be better for cakes, cookies, or other tender textured foods. However, the exact definitions, specifications, and naming of strong or weak flour vary by region and product standards. Before each batch of flour is packaged, it is usually subjected to quality testing. TSTS may include moisture, ash, protein, particle fineness, and processing performance. For bread flour, mills also pay attention to water absorption, EXTNSIBI and stability of the dough, because these properties affect fermentation, shaping, and baking results. When the flour meets the specifications, it is conveyed to automatic packaging lines. Machines fill full DGRAD paper bags, composite bags, or other containers to the set weight, then seal, code, and label them. Info RMATI on the package typically includes product name, ingredients or composition, net weight, production date, shelf life, storage instructions, and manufacturer details, following local lab EL engine regulations. The bagged flour is pallet ISAD stored in the warehouse, or dispatched directly to bakeries, food service suppliers, retailers, and household consumers. NODR production line turns flour into bread. Bread production starts with precise formulation and weighing. The basic ingredients are flour, water, yeast, and salt, with sugar, fats, and other components added, depending on the product type. Each ingredient contributes to the final eating quality. Automatic production lines mix the ingredients in the correct proportions. As the flour absorbs water, proteins form an elastic gluten network that can trap gases during fermentation and support dough expansion. The mixing time, speed, and dough temperature must be strictly controlled to ensure consistent product quality. The mixed dough enters a resting and fermentation phase. Yeast produces carbon dioxide, causing the dough to rise. Temperature and humidity are carefully managed, and different bread types may use different fermentation methods. FDR fermentation. The dough is divided into portions of similar weight by equipment, then rounded and shaped into the desired forms. Uniform sizing facilitates subsequent processing. The shaped dough undergoes a final proofing stage to gain its final volume increase. The end comes baking. As the loaves enter the oven, the yeast is inactivated, the dough structure sets, starch gel ATNECs and proteins coagulate, and hedatin ducat reactions produce the characteristic aroma of finished bread. After baking, the bread is cooled in a controlled environment. So-mi products are sliced uniformly after cooling, then packaged, boxed, and pallet ESD for dispatch to distribution centers. Potage flour and bread eventually reach a variety of consumer outlets. Behind these products lies a complete industrial chain from farming to processing. Processing also pays attention to byproduct utilization. Milling byproducts can be used in foods, feeds, and other applications. Straw can also be valorized. Modern agriculture and the food industry strive for a balance of safety, efficiency, and resource use. From the wheat field to the finished product, the entire production line is also a matter of precise timing. Every loaf of bread originates from a single grain of wheat that gradually matured in the field.